Hello, my fellow YouTubers. What's happening out there in the live world of live? Until the internet goes out and it's no longer live, it's in freeze frame. So go ahead, guys, leave your comments. Like to know who's watching. Oh, what's up? That's my boy Adam. Yo, Adam in the house. All right, we got some great things that I'm working on. I got in some goodies today, so I want to share them with you. So I've been gathering up, meaning I've been buying a whole slew of wire. So I got a bunch of magnetic wire. This here is 16 gauge, sweet 16. Sweet 16. You guys see that? Sweet 16. And I'm going to tell you something about 16 gauge wire. This is 14 gauge here, and it does heat up pretty fast when I'm just using 12 volts. Obviously car battery, not regulated. You know what I mean? So it's just wide open, which matters. I probably shouldn't even be doing that. But this wire here, by doing it that way, gets hot fast. 16 gauge wire, Ed realized that that was the sweet spot, because I've used 18 gauge and I have over here some 18 gauge. All right, I got some good magnetic 18 gauge, and this was too much capacitance, or not capacitance, too much resistance, I mean. So the sweet guy happens to be the 16 gauge. So I got that in. I got a 10-pound roll, really cheap too. So got that in, and I also now I'm starting to build an inventory. I got 22 gauge, I got 24 gauge, 5 pounds each. When you get into spinning up some coils, this guy right here, I suggest. It's a counter. It's dirt cheap. I think I paid $43 for this. Well built, geared, has a spindle and has a counter, and then a reset on the counter, okay? You could also, right here, you can turn it electrical by putting a belt over here, and it turns. So, and you take the handle off, okay? So I'll just suggest this. This one right here, I'm gonna spin that son of a bitch up. You know what I'm gonna do with that? I need unbelievable. Let me say that again. Unbelievable. Unbelievable. My internet. I gotta make it better. So I just ordered, my son plays a lot of games, so he's using up a lot of my internet. But I guess we're back. All right, so anyway, internet back. So they're running that feed line through the electrical lines in your walls. So it's riding the 60 hertz. Pretty cool stuff. Anyway, we'll get into that. It's a whole other subject. So, yeah, so spin this one up here. I'm going to just make an attachment. I'll make 2 wooden blocks, and I'm going to get a coupler that'll screw on here, and I'll extend this rod to go out as long as I need. And this right here is 24 inches, 25 inches. So I'll be able to spin it up, count how many turns. And if you guys are building your coils for your Tesla stuff, I advise you to use the Java Tesla coil app. You can download that, Java, and it pretty much you plug in what all the parameters are, and it tells you tells you everything, every single thing you can think of, as far as capacitance, inductance, how many turns, frequency, suggested caps you should have to balance them out. It's amazing. So you can use that as a great tool, as well as there's, what was the other thing? There is, I can't find it at the second, but I just want to give a shout out to everybody watching me live. I see that we got a few people out there. Internet bouncing on and off isn't too exciting. So anyway, so yeah, I'm getting ready to roll that up. That's going to be a new coil that I'm making, because the other ones, I got a lot to throw away. If you see here, I'm all burned up. You look inside, look in there. There's a trace line. It runs all the way down the inside of that Tesla coil. You know what that is? That's crazy. That's crazy. Listen, I'll put these things through murder. I torture these guys. This one's silicone. Look how thick epoxy I put on that son of a bitch. That's thick. Thick. And when it breaks out through this dielectric, it is so purple blue. It's amazing that the dielectric around this field here, or whatever the hell, this wire, the blue is amazing. It's purple. It's almost like Prince. So anyway, so if you look in here, and also I burned out the inside of that one. So that's coil A. That's pretty much trash. Where's the other one? We got another coil. I got all my coils are burnt out. So I have bought these capacitors that I think would use, and what I use right now is the bottle capacitors. And you hear Tesla talking about capacitance. Look at these guys. They're freaking huge. Freaking huge. They're huge. Look at that. Real thick. And these are good pulse capacitors. And these right here are 21,000 volts, right? So I'm going to shoot 15,000 volt, maybe 120 milliamps into it, okay? And each one of these is 1.5 nanofarads, 1,500 picofarads. Beautiful size right there. I think it looks like a cherry bomb. Bam! Look at that. So I got a couple dozen of these, and the difference between using these and the bottle capacitors, I will tell you through my experience with the bottle capacitors that they're more. If you look at a spring, and a capacitor is a spring. All right, guys, we just made it back from hyper losing internet speed. Back to the topic. So I'm trying to read your comments, but do me a favor. Somebody needs to post them like Tommy did. Tommy put them on when, so somebody needs to, whatever Tommy did, upload them or whatever. In fact, Tommy, please show me how to do that. I know Tommy's not on right now yet, but you can upload them so I can read them later, read the comments. But anyway, back to the spring effect, like the capacitor. So the glass capacitors have a more elasticity. So they're, I could blow them with 15,000 volts, 60 milliamps, but I have to have at least 1.5 inches, 1.25 inches gap. If I spread my spark gap out to where I'm testing now, I'll all of a sudden the system will shut down. There's a ground out in the capacitor bank. I turn off the NST and I go ahead and lift each bottle till I look and see which bottle is broken. they made the dead short in there. So that's how I find out what happens, and it usually is when I always experience that when I spread out the gap. And the reason we're talking about a lot of this Tesla stuff, we're really into the Ed Lee Scallen, and we're going to test the magnetic strength because now we got the 16 gauge wire I showed you guys. And we're going to talk about how much resistance and how many ohms we need to have to carry how much voltage and how much voltage and atom. Oh my God! In these notes here, Alrighty, everybody, we're back in space here in the St. Vincent Laboratory. I just looked up and noticed that there was no internet, so I don't even know what you guys heard. But I'm going back to here because if you watch it in the video, you'll be able to see what I was talking about. So I was talking about that you run AC from the wheel collecting in one part of this inductor. This inductor here is connected to the ground on Earth. So you connected it to one side, and that is the controlling side. The AC is going up there. And then the DC through a commutator on this wheel is the controller for the saturable reactor, which is saturating earth ground energies into this. All right, we're back from hyperspace, and I'm starting to call this bullshit. So I don't know what you caught on this, but I'm going to say you heard everything. You got to watch the video. So there you go. And I had this written a long time. So Adam, thanks for turning me back on to that because I started looking up that video. And Houston, we have liftoff. We're back from hyperspace. I'm losing internet. We'll see how this plays off on the video playback from YouTube. So, if I don't keep looking up, I'm talking to myself, I guess. So anyway, so you got the logistics of how all right, we're back again. DEFCON 5. So, the internet keeps going off. Terrible thing. Frustrating. So I'll have to better up the internet because I kind of like this live stuff. I like talking to you guys. I like you seeing it live. But if it keeps bouncing off like that, I'm just losing my concentration over here. I got a lot to talk about. I like to see who's popping up, who's watching. And I can go on and on and on. But anyway, so next time this... But, yeah. We got notes. We got AC current being controlled by a magnetic field of DC constant. This is freaking phenomenal stuff. This is almost like ruling the world kind of thing. That DC constant magnetic field is a controlling wave guide is what it is. And I think there's more to it than what meets the eye. I think it goes deeper and deeper into anything you're working on. You can associate it to. So if you guys haven't looked into it, just plug in YouTube and just look up magnetic controllers or also magnetic amplifiers, where you're saturating a core and with AC, low volts, 12 volts, and you have a couple other uh, inductors, and then you put a magnets up to it, and you'll see that it controls the brightness of that circuit there. So if it was hooked up to a light, it would be brighter, and you put the magnets back, and it gets down dim to nothing. So you can see that the wave is being controlled. And if you look at an oscilloscope, it's even better because it really shows that as you build up, one side has the sine wave, and the other wave is a straight line wave. But all of a sudden, it just starts to, as soon as you turn it up, it goes ahead and it turns it into a sinal wave as well. It's pretty interesting. So anyway, you guys, so far we're actually staying online right now. Holy shit. I keep looking up to see, I keep thinking we're popping out. Fascinating things here, because what we want to do is check the magnetic strength on these magnets. I got the 16 gauge magnetic wire in, and Ed always said the sweet 16, we're going to go with that, because 16 gauge, in between 18 gauge and 14 gauge, is the sweet wire to use. It allows enough amperage to go through the wire, and it doesn't overheat. So there's not too much resistance, and there's not too much open conductivity. So it definitely has a good presence about itself. So we're going to use that wire to wrap around these outside. We're going to remove this 14 gauge. We're going to take all this wire off. Now the good thing is I reuse this wire. So as you work in your workshop, you'll realize that throwing wire into a pile so you can sell it later is not good. It's good to have it to use. So here I am right now, rolling this up on top of a roll. So right here you can see that's a small roll there, and I'm going to go over it, and I'm going to collect my own wire. The cool thing about this test we did here many videos ago, we checked to see if we can use the magnet wire. This is one strand of wire. It goes 4 loops around each one, but it goes opposite direction on each one, okay? So when you have 2 wires at the very end, and you put a positive and negative at the ends, you either make that spoke there, that magnet, you either make it the magnet pole that it is. If it's north, it's north. Or if you put the poles in wrong, it becomes south. One wire. So, interesting thought. Leave your comments. Why? The interesting thought here is why, in one wire, how can you have different magnetic poles in one length of wire? And if the current is running through the wire over to the negative side, meanwhile each pole is staying to its true pole based on the proper wiring, that a magnetic field of opposite poles forms. And I can tell you why. Because basically, the wire represents all right, I think we just landed back to Earth. Welcome everybody. Hopefully the ride was good. Back again after disturbance with the internet. So, I'm hoping you heard what I was saying in regards to yeah, that's it. See, I have to do all that, lose my train of thought. It'll catch up. It'll catch up. Give me a second. Let me get this wire off of here. So just the fact that the magnetic field.
Hey, Dad?
Yes.
Can you come cut my meat?
Can you not cut it?
Huh?
Can you
She
not?
doesn't want me to.
Can you please?
She doesn't want me to. She said, you perfected it.
I tell her I'm doing a live video right now. I love to cut the meat. You're gonna have to take the reins, son. So, gotta cut the meat. He's asking me to cut it. I gotta go cut it. Anyway, so the fact that the core, the iron, is taking the energy coming out of the wire, which is pretty much like if you look at the wire this way, okay, this way, that each section of this wire is a disc, okay, is a disc. And that disc, like a CD disc, would have the either current running this way or it's running this way. Depends on what direction you wind it at. Is that interesting? That is crazy interesting, guys. Crazy. All right, so we got all the wire off. And I've been beckoned to go in and go cut some meat. So you guys, 7 people, man. Got some people following, huh? I think this is maybe a point where I just let my son take over. Be like out in the wilderness. Son, you gotta take control. Handle the meat. You can cut the corned beef. It's corned beef for Pete's sake. It's not like we're cutting a filet mignon. I hear you, my brother. All right, so wires are wrapped up, put away. I can use it for anything else, and this makes great contact wire. All right, Dan, you gotta go out. Get your butt out there. Get it going. Get it going. Get. By the way, when you're cutting corned beef, cut against the grain. All right, so when it comes to trying to figure out, we want to do a sample, right? And I found out with experiment, the best thing to do with you guys, if any of you who are watching live, comment into this. You have your own little shop. You got your own little setup, how you got things. You pretty much do with what you work, what you have. You work with what you have. And you always try to figure out deeply what is involved in what you got to build or even get into. And hold on one second. Alrighty, back. So I was looking for something that I made that is like a little Gauss meter for pull strength, but I don't know where it is, so I can't find it, and I'm not going to go hunting down right now, so I'll have to do it in another video. So based on the magnetic strength, we got right here these V-shaped iron, okay? And then we got right here V-shaped iron that is a magnet. Now this cannot be a magnet because it's soft iron. This is a annealed metal, so it's been hardened, and as metal gets hardened, but also this has alchemy or alkali batteries, I guess they call them. They're nickel, cobalt, nickel, copper, iron, something else, but that's the mix up in there so the molecules can realign themselves. In the soft iron, it doesn't stay magnetized, except for one thing. I gotta show you. I almost beg to differ why it would be 100% true, because here is my original PMH that I made. 1.5 inch square stock, beautiful piece. I made this 6 years ago, and I've been using it, hitting it hard with a coil. So if it doesn't hold magnetic strength, would it have a north or south pole? It should, right? Let's see if it does. That says south, right? That says south. That says north. South. North. So soft iron right here. Now let's get even brazing, and let's stick up a wrench or something lightweight that, if it has any magnetic strength, it would, I'm sure it would be able to hold a wrench. Let's just see.
Please leave your seat.
So I don't know if you caught that on that last losing the internet, but this is soft iron. Shouldn't hold any magnetism, and here's a iron wrench, and let's see if we can get it to stick. We can get it to stick. Okay, so soft iron does align itself in small doses, but it makes it great because of its alignment and just barely. I mean, this thing has been hit. You know, it's been hit with coils. Bam, 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 bam. So that alignment there, obviously, things throwing it at me. Obviously, this thing is so weak right now. I beat it down that its poles are all whacked out. I can tell just by looking of it. There you go. Look, that one, not even there anymore. That one's not there no more. That's there's north, south. Look, barely there, but barely. So that's for me just messing with the PMH on it, and bam, and hitting it at the wrong spot and the opposite pole, and it whacks these guys right out, puts them right out. But I can recharge them in a heartbeat. And next vid I do was I'll show you. I've been charging with 12 volts, you know, full battery, 13 volts, 0.30 I think is the charge battery. And then I have to find where I have this Gauss meter I made. And what you'll like about this is it'll help us with Ed's strengthening of his magnets to figure out exactly what strength do we need them to be in order to react. The main reaction I want is they're already magnets, but the main reaction I want them is with the pipe, with the ground, because we're gonna get into using the ground in different ways, and we're gonna mix up some different guys in there like Heaviside and Steinmetz, and we'll mix up some Edison. Edison's brilliant in himself. And then we're gonna mix up some of the Tesla stuff in there, and some of some Mr. Volts and Mr. Alexander Voltaire and Mr. Ampere, and we'll introduce some of the things that it takes to figure out more than just magnets and how we use them right now. More on how a pipe in the ground. That's the thing too that I've learned with electrostatics that you guys watch from those videos. The reason I even do those electrostatics is because I'm 100% fascinated with the reaction between the clouds and the ground, and how the air picks up, the winds are created real fast, and there's a major disturbance, and that's the reaction between the ground and the cloud. So those electrostatics is how I always felt that if you were going to get the ground to react, that's how you would do it. So that's what we're working on. We have all the main pieces here with Ed's wheel. Whether he did it or not, I have the wheel now. So the torch has been handed off to me, and ain't nobody else has got his wheel and taking it and trying stuff out. So the next video we'll do is with the Gauss meter. We'll check a couple separate magnets by itself. We'll check the iron also with wire wrapped around it, and we'll check and see what resistance we need in that wire and how much Gauss we're going to produce, which really affects the magnetic field, which also with that whole thing on saturated core, I believe, like Tesla knew, you're saturating that core underneath the Wardenclyffe Tower. So that saturation core that he spoke about, he had chambers, tubes underground that were made out of a conductive material, round 16-inch or 12-inch diameter tubes. And they also ran liquid through those to make them a superconductor, and I believe it was liquid nitrogen that was ran through those tubes, and they were inductive, and they also ran near the power supply, and there was a space in between them that I believe that was the dielectric space. And that power, that supply that was going in AC. So that's why, Adam, I was really interested in that when you sent me that, and I went to my notes, and those notes were for years back too. I remember that it was the Tesla patent that I read where he was mixing AC with DC, and that's, nobody talks about it. He was doing it in the ground. So basically he had a pathway from the main power supply place, which was the building, the brick building, running under the brick building over to the Wardenclyffe Tower, and then it had an underground network that was round, and pretty much ran, it was all copper or aluminum pipe, I think it was copper, and basically they were wrapped in tiles inside, surrounded.
Welcome, everybody. We're now in Dallas. Flight 714 has just arrived. Getting ready for departure. All aboard.
So we lost the internet, but obviously it's gonna be the last leg. Next time we lose it, we'll be done. So yeah. So what were we talking about? Jesus Christ. So how the Tesla's running the AC in one pathway underground, and in the same conductive area, he's running nitrous or liquid nitrogen. And in between the liquid nitrogen and the power supply, there's a field there that's built of a material that's of a dielectric. So you're building a super underground, you're building a super conductive atmosphere, almost like electrostatic in the ground, which is unheard of, because the ground obviously must be some type of electrostatic reactor, reactor, a satchable. So the ground, Adam, is a satchable reactor. There you go. Let's just go there. The ground is a satchable reactor. And how do you tease it? We're going to tease it with some DC and we're going to run some AC. And there goes Tesla's Wardenclyffe patent.